In this video, we will continue from the Crestron driver's load and test simple Windows video with integrating our driver file into a C# for Crestron program. We will begin by adding the driver and resources for the project and setting up the connection status feedback from our driver. In our test setup, we will use our same DIN AP2 as our device emulator, and our code will be loaded to a CP4N. We have already created a class library.NET 4.7 framework project and included the crestron.simplesharp.sdk.program NuGet package. We'll be triggering our driver from an X panel, so it has been declared and registered. We have also set up an enum with the join numbers from the panel project to assist in making our SIG_change switch case. Control system events and all comments from the default controlsystem.cs file have been removed for clarity. The driver project generated a .dll file when compiled. This reference will need to be added to our program to gain access. In this example, we will statically add the reference within the project and apply a using statement to gain access. We will also require additional references for using Crestron drivers. These references will be drawn from the SDK libraries folder. And for our driver, we will include radcom, raddisplay, and crestron.drivers.api.dll. To simplify our syntax below, we will also need using statements for crestron.rad.common.enums, .events, and .interfaces. We now create an object for the class and initialize the communications with our emulated projector device. For receiving status from the driver, we will subscribe to the state change and connected change events. For getting the driver up and running, we access the initialize and connect methods. Within the installation folder for the driver SDK, there is a set of programs and panels within the test tool folder that can validate all driver functionality. We will look at those further once the driver is further along. For our testing purposes, a simple X panel was created with 4 buttons for commands, 3 for feedback state, and a multi-mode button for connection status. Within the event handler method for connected changed, we will add a console print line to mark the event and update this analog value based on our status. Here, a ternary operator will set the value of our ushort based on the status of eValue. In our next video, we will complete our driver implementation with examination of feedback, control programming, and loading to our processor. Thanks for watching.